Hi, Math 2 in hand. Let's talk about determining the quadrant in which an angle lies. So number 1 gives me 7 pi over 4. That happens to be an angle on my unit circle I've been learning. That is the 45-degree angle in the fourth quadrant. So my 7 pi over 4 is my fourth quadrant, 45-degree angle. It's positive, so I'm going counterclockwise, and it looks like that makes it in quadrant 4. Number 2. Now, number 2 is an angle that's bigger than one rotation. I know that because if one radian rotation is 2 pi, then that's equivalent with a denominator of 4. That's like 8 pi over 4. So 11 pi over 4 is bigger than one rotation. So let's subtract 2 pi from it using 8 pi over 4 for 2 pi, and I get 3 pi over 4. This is an angle on my unit circle. It's my 45-degree angle in the second quadrant. So if I was to sketch this angle, I'm going to go all the way around once, spiraling out, and I'm going to go my 3 pi over 4 radians more. That's how I would graph or sketch 11 pi over 4. So it looks like my terminal side is in the second quadrant. Now, number 5 and 6 look a little confusing because they're just numbers. So these are radians. They're not degrees. They don't have a degree symbol, so I know that they're radians. And I need to think of my unit circle in terms of decimals instead of pi. So negative means clockwise. So this is 0 radians. This would be negative pi over 2 radians, negative pi radians, negative 3 pi over 2 radians, and negative 2 pi when I go all the way around clockwise. So let's think about these numbers as decimals. Negative pi over 2 is negative 1.57. Negative pi is negative 3.14. So already I realize negative 1 would lie in the fourth quadrant. It would be before negative 1.57. So I realize number 5 would be an angle in the fourth quadrant. What about negative 2 radians? Well, if I use my coordinate axes I already did, I knew this is 0, this is negative, so I'm going clockwise. So this is negative pi over 2, or negative 1.57. This is negative pi, or negative 3.14. And I can stop because I know negative 2 would be in between negative 1.57 and negative 3.14. So I realize that it is in the third quadrant. Let's do another one that is a decimal, 2.25, but this time it's positive. So this time I'm going to think about my radians going around my circle counterclockwise, because that's a positive rotation. And I'm going to change them. I'm going to do pi divided by 2 and get 1.57. Pi is 3.14. And I can stop there because 2.25 is obviously a number greater than 1.57, but it's less than 3.14. So it looks to me like that terminal side would be in quadrant 2. Let's jump down and take a look at number 14. It wants me to sketch this angle in standard position and state the reference angle. So something like number 14 is pretty straightforward. 4 pi over 3 is on my unit circle. I know that it is my 60-degree angle in my third quadrant. This is where 4 pi over 3 is. It's positive, so I go counterclockwise. So as far as a reference angle, remember, it's the angle formed by the terminal side and the x-axis. So I want this blue angle right here. Well, this is pi. I'm going to think about it with a denominator of 3, so it's 3 pi over 3. I need to find the difference between 4 pi over 3, my angle, and 3 pi over 3, which is the x-axis right there. When I subtract them, I get pi over 3. If you remember, I mentioned pi over 3, pi over 6, pi over 4. These are very common reference angles, and it was there. Let's jump down to number 18. Number 18 is 2 pi over 3. This is also an angle we know. 2 pi over 3 is in my second quadrant. It's my 60-degree angle in my second quadrant. So this is my 2 pi over 3. So if I want to find my reference angle, I'm looking for this angle between my terminal side and the x-axis. I want to figure out what this is, and this is pi. But I'm going to think about it with a denominator of 3 because I need to know how many radians are between 3 pi over 3 and that terminal side that's located at 2 pi over 3. When I subtract them, I get pi over 3 radians for my red angle. Let's take a look at a radian that is not in pi form. So remember, the 4 is a radian. It just has the pi multiplied into it. So let's number my my unit circle in the positive direction with my radians. And let's go through and use a calculator and do pi divided by 2 and get 1.57. Do pi, I get 3.14. Do 3 times pi divided by 2, I get 4.71. And I know that 4 radians would be located in the third quadrant. Unlike the other ones I do, though, it's not going to be one of my more popular reference angles. I want to find the space, the angle, between the terminal side and the x-axis. I want to know the space between this 4 radian, which is my angle, and 3.14, which is the x-axis. So I'm going to do my 4 minus 3.14, and I get approximately 0.86 radians would be that space between my terminal side and the x-axis. Let's jump down to number 22 and look at a quadrantal angle. So now this has been a minute, but last semester we discussed, I'm going to go past negative 90, past negative 180, all the way to 270. Quadrantal angles in our Unit 7 last semester were angles that were on the XY axis. They weren't in a quadrant. We called them quadrantal angles. So in this case, there is no acute positive angle between negative 270 and the x-axis. Sorry if my writing's super messy with my Apple Pencil, but there just is no reference angle in this situation. So there's no acute angle less than 90 between that terminal side and the x-axis, so there just doesn't exist one for a quadrantal angle. Let's take a look at the next page. So on the next page, you're to determine 2 coterminal angles. Now, this is also something that was covered in Unit 7 last semester. This is where last semester we worked entirely in degrees. So to find a coterminal angle, we would either add 360 or subtract 360, depending on the original angle we're given. Was it really, really positive? Was it really, really negative? And depending on what I wanted to find. In this case, I'd like to find one positive and one negative one. So let me jump down and do in a degree one first to kind of remind you from last semester. Negative 390 is really negative. It's wound up very negative. So let's unwind it by adding 360 to it. When I do that, I still get a negative degree. I'm going to use that as one of my coterminal angles. That's going to be my negative one. Then let's take my negative 30. Let's add another rotation, and I get positive 330. This will be my 2 coterminal angles with negative 390. They all have the same terminal side. So let's do one that's a radian. Let's do number 2 up here. So 2 pi over 3 is on my unit circle. I know that it's just in the between 0 and 2 pi. So in order to get a positive coterminal angle, I'm going to be adding 2 pi to it. And to get a negative one, I'll be subtracting 1 rotation. But if you remember, back in the day, if I'm going to add fractions, I need a common denominator. So this is like 2 pi over 1. And if I want to get a common denominator of 3, I'm going to multiply both the top and the bottom by 3. It's really 2 pi over 3 plus 3 pi, 6 pi. 6 pi, let me fix that better. 6 pi over 3, which gives me 8 pi over 3 as my positive coterminal angle. So the same deal here, I need to get a denominator of 3, so I'm going to multiply the top and the bottom by 3, and I'm going to get 2 pi over 3 minus 6 pi over 3, and I'm going to get negative 4 pi over 3 as my negative coterminal angle. What if something is really round up negative, and how can you tell? So first of all, you guys, I know one rotation is 2 pi. And if I'm going to put that over a denominator of 4, this is 2 pi over 1, I'm going to think about that then as 8 pi over 4. So I know that 9 pi is past that. So this is past one rotation in the clockwise direction because it's negative. So I need to unwind this from being really negative. So I'm going to add 2 pi to it. We just discussed why 2 pi over 1 is equal to 8 pi over 4 when I multiply both by 4, the numerator denominator. And I get negative pi over 4. That's going to be my negative coterminal angle. And now I'm going to add another rotation, another 2 pi to it in the form of 8 pi over 4. And I'm going to get 7 pi. Let me make that neater, sorry. 7 pi over 4. That's going to be my coterminal positive angle. Let's jump down here and take a look at 10. I think you can rewrite each of these in degree measure, but remember, if I'm trying to convert from radians to degrees, I need to cancel my radian, it goes in the denominator. I need degrees as my unit, it goes in the numerator. In this case, my pi's cancel, and I multiply the 3 times the 180, I divide by 2, and I believe I get positive 270 degrees. So let's take a look at the next section. So the first part, they want me to put it in terms of pi. So now I'm going to take my degrees, and now this time I'm canceling my degrees. So my degrees is going to be in the denominator. My radians are going to be in the numerator, and I'm going to get 150 pi over 180, and I can use my calculator to simplify that, or if I simplify by 3, I get 5 and 6. Looks like it should be 5 pi over 6 radians. And then it says rounded to the decimal equivalent. I don't really care about the 3 decimal places, but we're going to do 5 times pi divided by 6 on my calculator, and I get approximately 2.618 radians. Thank you. Oh.